Alright guys, so I'm gonna record a video real quick on the test review. Looks like lights off is a little bit better, but I realize you can't see it that well. Either way, you can see it enough, and that's what I can see right here on my phone screen. So, alright, I'm gonna start off with this graphing right here. So, remember when solving a system of equations, first of all, you need your answer should have both an x and a y, alright? So you need like x equals something, y equals something to be your answer, or you could have it in the context of like graphing as a coordinate, where you have your x coordinate and then your y coordinate, alright? So graphing is the easiest way to solve a system of equations. Starting off, you need to remember, hold on, I'm just trying to get a paper towel real quick. Okay. So you need to remember that if you're going to graph something, it needs to be in y equals mx plus b format. So right here, it's already solved for y. It's already in y equals mx plus b format. But an example of this same equation, but not in y equals mx plus b format, would be something like maybe y plus 5/3 x equals 3. And then you got to remember you need to solve this. So on the test, I'll probably put one that you have to put into y equals mx plus b format. So in order to do that, if I want y by itself, I need to subtract 5/3 x from both sides. Okay, so the 5/3 x cancels out. You get y equals -5/3, 5/3 x plus 3. Okay? And that's what the original equation was. I was just showing you an example of if you had to solve it, it would look like this, where the y is not by itself on one side of the equation. And you'd have to solve that by getting y by itself on one side of the equation. Anyway, when you do that, then your equation should be in y equals mx plus b format. So it would be like y equals -5/3 x plus 3. And I'm rewriting it because you might not be able to see this. And the one below it is y equals 1/3 x minus 3. So in both, well, let's go ahead and start off with this one on the bottom. Y solve for on both. So once you have that, notice there's a number next to the x and there's a number by itself. The number next to the x, that's your slope. The number by itself, that's your y-intercept, or your starting point. Okay. So I'm going to start at -3 on my y-axis. So that's where I put a dot. And then remember, slope is rise on top and run on bottom. So I'm going to rise 1, run 3. Rise 1 from there again and run 3 again. Now I have enough information to make a line, really. Notice rising 1 and running 3 is the same thing as, going down 1 and going left 3. Down 1, left 3. Down 1, left 3. So there's my line. That's this line right here. Okay. And my next line starts at +3, and it goes down 5, right 3. So down 1, 2, 3, 4, 5, right 1, 2, 3. So right there. Down 3, 4, 5, right 1, 2, 3. This is me estimating, but somewhere in there. It's probably more accurately right there. But anyway, here's the crucial point right here. That's the solution. So notice the solution is right 3, down 2. So my solution to this system is at 3, 2, or when x equals 3 and y equals 2. Either of these answers, the coordinate would be an answer where you have x is 3 and y is 2, or you can write out literally x equals 3, y equals 2. Okay, so there's the first one. I'm going to graph the next one without actually talking so much. So remember that your slope, in this case, is just 4, so you can always put it over 1. And the next one, remember if you have -x, you have -1x. Okay, -1, you can always put that over 1. Okay, so I'm starting at -2, graphing this one, starting at -2. Then from -2, I'm going to go down 1, right 1, down 1, right 1. I'm going to rise -1, run 1. So over and over, down 1, right 1. Okay, so there's that equation. This one, start at positive 3. 1, 2, 3, go up 4, right 1. Ooh. So think about this. Up 4. 1, 2, 3, 4, right 1 would be, I'm estimating right there, but that's the same thing as going down 1, 2, 3, 4, left 1. So down 1, 2, 3, 4, left 1. Down 4, left 1. So it looks something like this. All right, there's my intersection. So either of these answers would be fine. X equals negative 1, y equals negative 1. Or you could write it like this. X equals negative 1, y equals negative 1. That would be the solution. So when it says to solve each system by graphing, solving would be able to say, you know, you need to graph it, but be able to say, here's my solution. X equals negative 1, y equals negative 1. All right. Solve each system by elimination. I'm going to do these quickly. So elimination, it's the idea of adding two equations really together to eliminate a variable or to get rid of a variable. So when I look at number 1, which says negative 4x and positive 4x, I realize because they're opposite signs and you have the same amount of them, when I add them together, a negative 4x plus a 4x are going to cancel. Then I have negative 2y and 8y, that's 6y, equals negative 12 and negative 24 is negative 36. Continue solving for y. So divide by 6 on both sides, y equals negative 6. So remember, a system has a y equals and an x equals. So I have my y equals. To get my x equals, I can just take this. I'll go ahead and write it in black and write it, or plug it back into, substitute it into another one of my equations. I'll put it in the bottom one. So the bottom one says 4x plus 8y, and when y is negative 6, we got that, equals negative 24. So 4x plus 8 times negative 6, so that's going to be actually minus 48 equals negative 24. I'm going to add 48 to both sides like this. Those cancel. So 4x equals 48, 24. So that's going to be 24. X equals positive 6. And I got that part. So negative 24 plus 48 is 24. 4x equals 24. I divide by 4 on each side. So 24 divided by 4 is 6. So here's my answer. X equals 6, y equals negative 6. So again, if I'm going to graph that, it's going to intersect. My two graphs are going to intersect at 6, negative 6. All right, next one. I'm going to skip to 3. I'll just talk about them real quick, but these are ready to add together. So the reason I'm skipping them is because I don't have to multiply by anything. I just add those cancel. So 4x, negative 4x. I add the y's cancel in this case. Negative y and a positive y would cancel. So that'd be like 3x equals 11 plus 19 is 30, and then I'd solve for x from there. This one I just add negative 6x and 6x cancel, so I have 9y equals negative 9, and I solve from there. I want to do one that's not going to cancel. So number 5 right here is not going to cancel. So number 5 says negative 2x minus 9y equals negative 25. I'll rewrite this real quick. Negative 2x minus 9y equals negative 25, and negative 4x minus 9y equals negative 23. So if I were to add these together at this point, nothing's going to cancel. Negative 2x plus negative 4x is negative 6x. Negative 9y plus negative 9y is negative 18y. So I don't want to add these just yet. I want to first look at this and see which of my variables do I want to cancel, the x's or the y's. And ultimately it doesn't matter, but typically it's easier to cancel one versus the other. Like for example, you have a negative 9y and a negative 9y. When I look at those, I see them as very, very similar. So if I could take my top equation, and this is where you have to multiply sometimes, or slightly change your equation, multiply the entire top equation by negative 1. The reason I'm doing that is negative 1 times negative 2 is positive 2x negative 1 times negative 9 is positive 9y. Negative 1 times negative 25 is positive 25. So I rewrote this equation now. I rewrote this equation, sorry. And what it is it's the negated version of it. So it's negative. Notice every single sign is switched. Now the benefit of that is, now if I add these two equations together, I have negative 4x plus 2x, that's negative 2x. Negative 9y and a positive 9y. That's the reason I did that. Okay, that's the reason I multiplied by a negative. So that those would be opposite entirely and they would cancel out. Equals negative 23, positive 25, that's 2. I'm going to divide by negative 2. So x equals negative 1. I've got my x. I'm going to take it and plug it back in to get my y. Alright, so I'm not going to do that for you guys on this video, but I would recommend just taking it, putting it in right there for that x. So you have 2 times negative 1 plus 9y equals 25. And you can go ahead and solve. Alright, let's see if there's another good one to do. So, let's see. Number 6 says 8x and a negative 3x, and then you have 2 positive y's. So what I'd recommend doing is getting rid of the y's. I'd multiply, again, one of my equations by negative 1, and that should be enough. Same thing as number 7, you can get rid of your x's right here by multiplying one of the equations by negative 1. You can get rid of your y's on number 8 by multiplying your equations by, or one of your equations by negative 1. Okay, going on to the next page. Alright, substitution. So now, transition, I've talked about graphing to solve a system. That's where you find the intersection. Talked about elimination, where you're adding two equations together and getting one of your variables to eliminate. Now here's substitution. The idea of substitution is you need to solve for one of your variables and plug it into your other equation and solve again. And you're really just repeating those steps. Solve, substitute, solve, substitute, solve, substitute. So, first step, solve for one of my variables, whichever one is easiest. Now, if you look at this top equation, if you can't see it, I'll rewrite it. It says y equals 6x minus 11. Well, here's one of my variables. Notice it's on one side of the equation by itself, meaning that it's already solved. Okay, it's positive, it's by itself, it's already solved. So, the solve for one of my equations, or my variables, it's already done. Here it is. Now I'm going to take that and I'm going to plug it into my other equation. So here's my other equation. It says negative 2x minus 3. I'm going to write y out here kind of by itself. Minus 3y equals negative 7. Now the reason I wrote y out here by itself is because this says that y is 6x minus 11. That's the whole reason we solve for it. So now we have something that y is. Y is 6x minus 11. So instead of writing y here, I'm going to write another way. I'm going to put another way of writing y, which is y is 6x minus 11. So now I have negative 2x minus 3y equals negative 7. So multiply this out. You're going to distribute negative 2x minus 18x. Negative 3 times negative 11 is plus 33 equals negative 7. Combine my like terms. Negative 18 and negative 2 is negative 20x plus 33 equals negative 7. Subtract 33. Negative 20x equals negative 40. Divide by negative 20. So x equals positive 2. And that's really it. Now I need to solve for y, which gets really easy. Because remember, a system has two answers. It has the x equals and the y equals. So what does y equal? Now we know x. So let's find y by putting the x into this equation. So I have y equals 6, x is 2, minus 11. Y equals 6 times 2 is 12, minus 11, so y equals 1. So there's my answer to number 1. X equals 2, y equals 1. Again, if I graph this, you would find that it intersects at 2, 1. Alright, so looking at number Let's do one more of these. Number 2, again, something is already solved. This one says y equals x minus 1. It says it right there. Y equals x minus 1. So I'm going to take that and put it into my other equation. So 2x minus 3. Now instead of writing y, I'm going to put what y is, x minus 1. And again, the benefit of doing that is, notice I have no y variables here. Okay? So let's multiply it all out, combine some like terms. 2x minus 3x plus 3 equals negative 1. Combine like terms. 2x minus 3x is negative. X plus 3 equals negative 1. Subtract 3. So I'm going to write below negative x equals negative 4. Divide by negative 1 to solve for a positive x. So I'll just write it over here, or up here. X is going to equal positive 4. Okay, so next one, take that x equals 4 and plug it into one of your other equations, any one of your other equations, and solve for the y. So right here, y equals 4 minus 1. So y equals 3. Let's see. I'm going to talk about something, and I'm not going to work it out, but I'm going to talk about, let's see if I can find a good one. No, well, never mind. I think that's it. So that's it for this video. Let me just graph one more just to end it. Right here, it says, so it's already solved for y. It says y equals negative 1 half x minus 1. So start at negative 1, and then my slope is, I'm going to put that negative up top. So remember, if you have a negative in the middle, just, you can put it up top or on bottom. I typically put it up top. So down 1, right 2. So from here, down 1, right 2. Down 1, right 2. Down 1, right 2, like that. So there's one line. My other line says y equals 1/4 x minus 4. So it starts at negative 4. And then it goes up 1, right 4. So up 1, right 4. Up 1, right 4. So I'm not going to really make a perfect line. I can already see my answer. It's right there. My answer is at 3, comma, oh, I'm sorry. It's at 1, 2, 3, 4, comma, 1, 2, 3. Okay. 4, comma, negative 3. Or remember, I could write my answer as x equals 4, y equals negative 3.